A very good afternoon to all of you. Today we are going to start a new civil engineering subject, that is fluid mechanics. Fluid mechanics. In fluid mechanics, we are going to deal with the basic concepts of fluid mechanics. This is just an introduction lecture. What we are going to study today is introduction to fluid, introduction to fluid, and fluid mechanics. First of all, I will combine this word, that is fluid. It is made of two words, that is fluid and another is mechanics. What is this fluid? First, I am going to explain this. Any substance which can flow is called fluid. Now I will explain you what is this substance. There are two terms you are going through. What is this substance and what is this flow? You know that substance is what? Substance is having finite mass, substance will occupy space, and substance is tangible. Tangible means that we can feel. So these are the three properties of a substance. And next is, what is fluid? What is flow? What is flow? If I will take a coordinate system like this, and we have different particles like this. These are the particles. Relative change, we can define flow as relative change of position of particle with respect to time. This is called flow. Now you already understood the term, that is fluid. Any substance which can flow is called fluid. I already explained what is substance and I already explained you what is flow. Now next term is I will explain you that matter is made up of, or matter is of three types. One is solid, another is liquid, and another is gas. If we see this solid, look at this solid, we have defined the flow. Fluid as substance which can flow. Solid, you know that solid can't be able to flow. So solid is not a fluid. But the liquid and gas, liquid and gas are the two substances or the two types of matter which can flow, which can change the position with respect to time. Okay, like, so we can conclude from here that liquid liquid and gases are fluid are fluids. Liquid and gases are fluids because both can change their position with respect to time with respect to time. I hope up to here it is very clear to you. Now fluid has some properties, like fluid has mass, fluid has fluid does have certain shape and it occupies shape of vessel which can flow under its own weight. For example, this, let's take an example, like take an example of glass. For example, this is an empty glass. This is an empty glass, and you will pour some liquid in it. Definitely you will pour some liquid in it. This is the glass, and you are going to pour some liquid in it. This is the liquid in glass. Definitely you will notice one thing, that the liquid will take the shape of the glass. This is what it explains, that it occupies space of shape of vessel which can flow under its own weight. If you tilt this glass, the liquid will flow out from the glass. This is all about fluid introduction. What is fluid? Okay. I hope you got this concept. Now I'm going to explain you that fluid mechanics, fluid mechanics. Now already explained you what is fluid. Now next term, that is mechanics. That is mechanics. What is this mechanics? It is a study of, it is the study of forces, forces and effect of forces, effect of forces. What is that? For example, this is a block. This is a block, and you are going to apply some force from here. You applied a force F. This block may accelerate. This block may change its position. That is, change its position. If this was its original position A, now its position will be this one. Now if we consider this point as B, what happened? In fluid, in mechanics, what you will feel that if you will apply a force, this object is going to change its position, or sometimes it is going to deform. Here, this object has changed its position. Okay, this object behaved as a rigid body. Sometimes it deforms. Okay, sometimes it deforms. All comes under this mechanics. That is a study of force and effect of force. What is the effect of force? Is that the change in position is an effect of force. This is an effect of force. Effect of force. Now, fluid mechanics is broadly divided into fluid mechanics. What you have to study, that is study of, now you got the concept, study of fluid and effect of force on fluid. Effect of force on fluid. Okay. Fluid mechanics is broadly divided into fluid mechanics is broadly divided into two types. One is fluid. One is fluid at rest. Fluid at rest. And another is fluid in motion. Fluid in motion. The fluid at rest, this branch is called as fluid statics. Fluid statics. And fluid in motion, this branch is called as fluid dynamics. Fluid dynamics. Fluid dynamics. These are the broad classification of fluid mechanics. Now we will give you another concept, that is microscopic and macroscopic approach. Macroscopic approach. What is this? In microscopic approach, you are going to study each molecules, each particles. Separately, you will study each and every particle, that is microscopic level. In macroscopic level, you will study a whole mass, like this whole section of the fluid. Like this is the whole section. You are going to study the whole section. This is the section. You are going to study this whole section in macroscopic level. In macroscopic approach, you are going to study whole section or whole mass. In microscopic, you will study each individual particles. Okay. Now, macroscopic approach of fluid. We mostly rely on this because it is easy to study macroscopic as compared to microscopic. Okay? In macroscopic, we see that the assumption of microscopic is that there are no voids between molecules. That means the mass, there is continuous distribution of mass. There is continuous distribution of mass. This is the basic assumption in macroscopic approach, that there are no voids between the molecules and there is continuous distribution of mass. मास जो है वो बिल्कुल कंटिन्यूसली डिस्ट्रीब्यूट है, कोई भी उसके बीच में voids नहीं है. ठीक है guys, like this, if you will see like this, there is continuous distribution of mass or molecules and there is no void space between these molecules. This is called continuous distribution of mass. This is called continuous distribution of, like this same way. This is called continuous distribution of mass. Now to study this macroscopic approach, there is one number, that is Knudsen number denoted by Ku. What is this? Ku equal to mean free path. It is the ratio of mean free path divided by characteristic length. Mean free path is denoted by lambda and characteristic length is denoted by L. What is this mean free path? For example, you have three particles like this, 1, 2, and 3. Okay. And the distance between them, if they will collide with each other like this, they will collide with each other and they will arrange themselves like this. Okay. They will arrange themselves like this. If they travel in this direction and they arrange like this, themselves like this, they travel along this direction and they will move along this direction. If there are these particles, like if this particle will collide with this particle and this particle will collide with this particle and their path is like this, their path is, they will first go here and then here. Now, if you want to check their mean free path, this will be their mean free path. This will be their mean free path. This will be their mean free path. Mean free path. This is their mean free path between the particles. And if you take any section, for example, this is the boundary. This is the boundary. If you consider you have taken these particles in this section, the length of this section will denote the characteristic length. I hope you got this point, that mean what is mean free path and characteristic length. Characteristic length is the section from where you got these particles. Okay, you have chosen these particles, just an assumption. Now what you got this concept from there, you get that if Nunez number is less than Ku is less than 0.01, then there is continuous distribution of mass. Continuous distribution of mass. Then there is continuous distribution of mass, or that is called continuum. Continuum. And if your Ku is between 0.01 and less than 10, then there is slip flow. And if their Ku is greater than 10, then there is free molecular flow. Free molecular flow. Free molecular flow. What is this slip flow? Slip flow means if this is the boundary layer, if this is the boundary, okay, if the fluid particles slip from the boundary, this is slip flow. Free molecular, what is this? If they were slip, free molecular flow means the particles will freely flow around this boundary. Okay, the particles will freely flow around this boundary. In the next chapter, this was all for today, and I hope you got everything what I have told you. You got the basic concept of fluid mechanics, and in next chapter I am going to discuss the further properties of fluid, and this was my first lecture, and I hope you have liked this video. Do subscribe my channel and do share and do the comments. Thank you. Have a nice day.